Good morning. So I'll tell you a little bit about Axiom Space. Basically, we're a space infrastructure company with an emphasis in human spaceflight. That includes things like the Axiom Station here, which is part of the International Space Station and the foundation of our Axiom Station. So if you're familiar with the movie 2001, Arthur C. Clarke had a grand vision of what humans living and working in space would be like. Giant rotating space stations, lunar bases, transportation hubs, and spacecraft. That turns out to be a very durable vision considering when it was done. Remember that this was before Apollo. This was even before the first person had been launched into orbit. So when Axiom Space looks at what is people working and living in space look like, we kind of broke it up into three phases. The first is what we call our private astronaut missions. And really this is about to expand the access and opportunity to the International Space Station. So countries that typically haven't been able to have a human spaceflight program can now partake in that. It also provides additional opportunities for those countries that already have an existing space program, but want to have more of it. Phase two is about expanding the capabilities and capacity, really scaling the capacity of the International Space Station by adding additional modules that provide crew, life support, research and manufacturing accommodations, and a whole host of new capabilities from a commercial sense. And then phase three is about anchoring a foothold in low Earth orbit. Basically, when ISS retires at the end of 2030, we will continue that mission and provide a continuous human spaceflight presence on orbit. So for phase one, these are our private astronaut missions. We've conducted 3 so far. We have another one scheduled later this year, early next year. And you can see by the complement of crew that it's very international. These are not sightseeing missions. These are very research-heavy missions. Each crew member has their own portfolio of research and is scheduled in 5-minute increments throughout their duration at the International Space Station. So AX1 and 2, they had over 25 experiments and hundreds of hours of research, and then AX3 basically doubled that, up to 50 investigations that were conducted. So you can see AX1, we had a Israeli and a Canadian. AX2, we had Saudi Arabian crew, including the first female Saudi astronaut. And AX3 was branded our all-European crew from Italy, Sweden, and from Turkey. So let me just give you a little taste of what a PAM mission looks like. So if we can roll the video.
For some reason, every time I think about the countdown, it starts at T-7 seconds. I don't know why. 7, 6, 5, 4, 3, 2, 1.
Jake, everybody. This is a Spaceship Freedom. Here we are above the Earth. Amazing ride uphill. We're very proud to be representing Axiom and our nations here. I couldn't be happier to be here and prouder of my guys that just did a great job all the way uphill.
On behalf of the Expedition 70 crew, I'd like to welcome Axiom 3 on board the International Space Station.
Welcome aboard Axiom 3 station. We are now resuming operational audio communications.
I am very proud of my AX3 crewmates who helped their agencies achieve all of their science objectives, technology demonstrations, as well as the outreach events.
So what I really hope this experience as a family will bring to them, it's the self-confidence that nothing is really impossible. I want to be an example, and I want to be part of those that make something impossible possible.
This is not a mission of a single individual. This is not magnifying a name. This is just the ignition moment. This is not the end. This is just the beginning.
So as part of our phase 2, we're building out our capability on orbit and extending to the moon. We won a contract, basically a services contract from NASA to provide the lunar suits for Artemis 3. This is a engineering prototype that we've got working right now. It's quite a bit of improvement since either a shuttle or the Apollo suit. A lot more mobility. Mobility was a key thing. So if you remember the Apollo astronauts, they like to hop around the surface. And that was because of the constrained mobility they had in that suit. Basically, the hips, there was no rotation, so you couldn't have a walking cadence. With these suits, we built in the joints in order to give that degree of freedom so that they have a more natural gait. The life support system is much more capable than in Apollo or even for the shuttle suits or what they use on ISS today. Also, building out the ISS. So we provide multiple modules, and basically the idea is to double the capability or capacity of the International Space Station. So we can double the number of crew that are there at any time. This greatly increases the amount of research that can be done on the station. We have dedicated modules that will provide manufacturing space. On-orbit manufacturing is one of the huge growth areas, and so there's facilities to accommodate that, and then the power and thermal module, which is really all the utilities and the base infrastructure that is needed to operate the station, come together, and then once ISS retires, we were able to separate from ISS and basically continue that mission on. So. I'd like to show you a little bit about the progress we're making towards building that space station. If we could have the video. We are building the world's first commercial space station, one element at a time.
We think that what we're doing is for everyone, everywhere. This is a global endeavor. Our partner, Thales Alenia in Italy, is in the finishing stages of building the first module, the first pressure vessel.
We are here in the integration and manufacturing area of Thales Alenia Space. Here we have the two cones that will be part of the module. Is also the gate to the module, to come in and to come out. The very big cylinder that will be the core of the module. Just to have an idea of the dimension of the real module, you can see me compared with the structure. On these ports, all additional modules will be docked. This is the most complex piece of the entire Axiom module.
We're on pace to build a human-rated spaceship faster than anybody's ever built one.
When we look at our roadmap, we look to see how we can double its capability every 5 years.
It requires a lot of different talents and a lot of different engineering backgrounds, so we've really expanded the team.
I'm working on the time-sensitive network aspect of the space station. So that's the network, have all the flight computers synchronized and actually do the thruster firing at the perfect time.
So this is the command trailer. We're able to control our test stand, which enables us to vary our set pressures, our flow rates into the thruster in order to collect performance data at various OFs and chamber pressure conditions. It's always a blast to come out here, set everything up, and start lighting rockets off.
Behind us, we have the carbon dioxide removal subassembly.
We're going to be creating the most integrated ecosystem that has ever been put into space thus far, which is a really cool thing to be able to say.
I fabricate PC boards and cables and harnessing. This is a life-critical job, and you want to make sure you do the best possible job.
"15 to 20 years from now, we're going to be surrounded by objects that we can't imagine how we live without, that were manufactured in space." I think there's another promise too, and that's why I'm really excited about the X2 crew. There is this effect that people have gone to space and had. This is called the overview effect. Many people have come back profoundly changed because of their experience. And I think the more people that we can have that see the world as the whole world, the better off we all are.
So phase 3 is basically independent operations. So this is basically post-2030. This is after ISS is retired. This is our core configuration that we're providing services globally to parties for either economic development or for national interests. But this is just the start. If we look at Arthur C. Clarke's vision, we're on that path to provide that infrastructure that provides the population of the Earth access to space. And with that, I'm going to bring out my colleagues, Branden and Joe, that are implementing our digital transformation. And if they can come on out.
Howdy, everyone. Thank you so much for welcoming us. We're very excited to be here today. My name is Branden Ramsey. I'm the Senior Director of Digital Transformation here at Axiom Space. And before I introduce my colleague here, I wanted to give you guys a little bit of my background. So my background is primarily in computer engineering and systems engineering. I started out my career in aerospace, had a couple of stops along the way, and then ended up in oil and gas exploration. Along that path, I had some really cool projects that I had the privilege of working on. My first was a hardware and software solution for the International Space Station that is currently still running today and still floating miles above our head. And then I had the opportunity to do software and firmware for downhole tools in oil and gas exploration that are operating miles below our feet and things in between. In 2020, I decided to make a change. I don't know if that was a significant year for you guys, but for me, I made a change to leave a very stable job and join 64 other people attempting to build the first world's commercial space station. If that gives you a little bit of an uneasy feeling, you guys should really speak with my wife on that one. But I did that, and the reason I tell you that is in September of 2020, I joined Axiom Space as employee 65. And in early 2023, we crossed the 1,000 employee mark. So you can understand how rapidly we've been growing and some of the changes that we've met along the way and challenges as well. So I'm going to hand it over to Joe to introduce himself.
Thanks, Brandon. My name is Joe Torres. I'm a digital solutions specialist in our EVA business operations office. I'm also a certified spacesuit engineer and technician supporting manned pressurized testing.
All right, great. And so you guys already met Dr. Baine, and he gave you kind of what our vision is at Axiom Space. And that vision is to make space more accessible to everyone, right? What Joe and I would like to talk to you about is some of the challenges that we meet along the way in doing that. Now, some of them are specific to building a space station or a space suit, but many of them are common. And those are the ones that I want to talk to you today, as well as talk about how Appian is helping us solve those problems. All right, what I wanted to first kick off is where we kind of find ourselves today. Some people call this Industry 4.0, others call it the fourth industrial revolution, but it's really transforming of the traditional manufacturing and business processes, mingling them with digital technologies, analytics. It's characterized by things like the cloud or Internet of Things or generative AI, and it's blurring the lines between that physical and that digital. It's fundamentally altering the way that we live, work, and interact with one another. But with all of these advantages come some challenges. The first of which is engineering complexity. So as we go to solve more and more challenging problems or more and more complex problems, we're having to have more and more complex solutions. So as an example, what you'll see over on the left-hand side is the Space Shuttle, which retired in 2011. At the time of its retirement, it had roughly 400,000 lines of software code. But what you'll see on the right is just a modern-day car, which has over 100 million lines of code. So as you can see, things are becoming more and more complex. And you see that in your own life. If you think about your first car to what your car is now, or your first phone to what it is now. For some of us in this room, that is quite a bit of change, going from to having the world's knowledge in your pocket. All right, next I want to talk about another challenge that we have, and that is our designs are becoming more integrated across the disciplines. And what I mean by that is the mechanical and the electrical and the software are all blending together in order to solve these complex solutions. But the challenge is whenever we tightly couple our systems like that, a small change can cause a ripple effect throughout the system. A software bug can now bring down an entire system, or a software update. Next, I wanted to talk about data management. So as we're creating these more integrated systems that have more feedback and monitoring in the electrical and software domain, we have more data than we've ever had before. And the challenge is, how do you organize that data? How do you find that data? And how do you bring it together so that you can find that needle in the haystack of the information that you're actually wanting to use? Or, more importantly, how would you hand that over to something like generative AI or LLMs? The key is this data management and making sure it is properly organized. All right, and then on top of that, as my astronaut friend is stressing here, it's hard to find the talent necessary to solve these problems. So we're in a very competitive market. We need these highly technical skills. New positions that never existed before are being created today. We have prompt engineering, which never existed before. And so we are all struggling as businesses to find that talent that we need to solve these challenging problems. And so there is an increased talent shortage, and the demand is far outpacing the supply. All right, so what do we do here, right? Who brought this Debbie Downer to this conference and just talk about all the hard things, right? So how do we solve these problems, right? Well, I would actually argue that the way that you solve some of these problems that are created by these various technologies is by leaning into them more. What I mean is you lean into the digital realm more. You lean on generative AI to solve these problems. And this is sometimes referred to as digital transformation. All right, so I'm going to break a little bit of a cardinal sin here, so bear with me. I'm going to read you guys a definition. All right, but I think it's important that we synchronize on this term digital transformation because it can mean a lot of different things to a lot of different people. All right, digital transformation refers to the process of integrating digital technology into all aspects of the organization's operations, fundamentally changing how it operates and delivers value to the customer. The goal of digital transformation is to enhance efficiency, improve decision-making, and ultimately drive business growth and competitiveness in the new digital age. So when I was looking for this definition, I searched a couple of different sites. I really wanted to make something that was summarized, that was easy to follow, and that really fit kind of the audience that we are today. So I went to my favorite source, which is ChatGPT. So it's a little tongue-in-cheek here, but this is an example of where we are today. It's a pretty good definition that came from generative AI and LLMs. It really, I could change the voice I could give it inputs about who I was speaking to, who my audience was, and it crafted a message that fits the goal. So now that we have a definition of digital transformation, I want to talk about one of the most important tools that come with that, and that is your digital thread, or digital fabric, if you will, right? And so the challenge is that we talked about that data management, is as we move along the engineering lifecycle, and we may start with just a hand-sketched drawing, for instance, in the concept phase, and then we move on to design, testing, manufacturing, operations, even retirement. Each one of these stages generates data. Some of it is in paper form, some of it is just in institutional knowledge, and then some of it is obviously in various software. But you will notice each one of these phases could generate data in different formats from a software perspective. You may have CAD early on in your design. In the testing, you may have analysis, verification. They're all coming from different softwares. And so how do we gather all that data to create this digital thread that connects it together so that we know we have accurate information and so that we can ask intelligent questions from our own ChatGPTs that we hope to create? But the problem's even a little worse. It's not just the engineering lifecycle that you have to manage. There's also the business lifecycle. Each one of those generates unique data that needs to be connected so that our decision makers can make better decisions up and down the chain. This is where Appian is coming in to help Axiom. So what you'll see here is a high-level view of some of the software that we use, more or less the backbone or our software stack. We interface with things like Box, JAMA, Jira, PDM, that controls our engineering lifecycle. That's where our tasks live, our requirements may live, as well as our SolidWorks, drawings, documentation, those types of things. Over on the right-hand side, you will see we're integrating with two different systems that involve our ERP, our costs, our inventory, those types of things. And then we would move on to manufacturing. So I won't go into too much detail here. I'm going to hand it over to Joe. He'll talk a little bit about it. But Joe also has an afternoon session where he'll talk about more of the specifics and what we're solving here. So Joe, take it away.
Sounds good, Brandon. I'm going to talk a little bit about my Appian journey. So I started off with Appian about roughly 6 years ago, shadowing a Appian professional services team in the oil and gas sector. They were very talented and scaled a solution capturing design of service details along with mobilization of equipment and personnel to and from the rig site. During this process, we learned a lot about how a team can quickly build an application, gathering quick requirements and scaling those through in an agile fashion through solutions delivery. Flip side of that, I also helped with the project management of the SAP web service endpoints that allowed Appian to pull data from SAP as well as schedule equipment to the various BOMs on these jobs through Appian process models. Did that for a few years and then saw a wonderful opportunity open up with Axiom Space and interviewed with Branden Ramsey here, my colleague, essentially coming in to learn about the various tool sets, engineering services, as well as stand up our cost point ERP structures. And learned about most of these data silos and it recommended that Appian platform be the prime integrator to solve that problem. So our first application we built was a collaboration tool for NASA to provide insight and request data for our spacesuit program. Through review workflows, technical documentations, DRDs were passed through these Appian process models with ability to comment on these things. It was a huge success, and then the word got out, and then everyone wanted an app, and we know what that's like. I was very appreciative of services from CST to scale these operational needs and turn idea into function. During this process, some of the engineering teams needed some assistance down in the lab, and they asked me if I'd be interested in learning more about becoming a suit engineer. And I was like, wow, suit engineer, what's that about? And they just come down to the lab, shadow us, and see if you can learn. So I went down to the lab, and one of the suit engineers had a paper-based form where he was tracking all of the components and configurations of the spacesuit on the donning stand. And we would assist the test subject to get into the spacesuit and start, taking down the calculations and the different configuration changes that the test subject was describing in terms of like pain points, hot spots, if you will. And if there was a change, the engineer literally took a pen out of his pocket and crossed it out and wrote the new value. And at the end of this run, he'd go back up to his desk and grab this piece of paper, put it on a printer, scan it, and put it in box. So I studied this form, and I said, wow, I really think I could build an Appian app for this. So I went home that weekend and created an application backed by records with the sizing sheet mentality in mind to capture hardware details, configurations, and put it on an iPad, went back to the lab Monday morning and handed it to the technician and asked him if he can perform a fit check on this. And he was like, wow, we've been trying to go paper-based for 30 years, and you did it in like 2 days. Yeah. It was a rewarding piece of feedback. And more recently, we partnered with Appian Customer Success to improve our engineering processes of ordering non-class and class-based flight hardware with insights into our procurement system from order initially received to goods received on the dock. And all this is kind of building that data fabric around inventory, around procurement data, documents, procedures, all stitched together through record-based relationships. In short, it's been a privilege developing in the Appian platform, and I'm excited to see where we go with human spaceflight.
Awesome. Thank you, Joe. Yes, this is an example of the application that Joe is referring to, where people can enter flight hardware, as we call it, that will allow them to track it end-to-end across several systems that we were showing earlier that kind of bounce back and forth. I'd also like to show you some of the future states that we're hoping to do. So we refer to this lovingly as Bubble Man. This is not our actual spacesuit, so that my compliance team doesn't drag me off the stage. But what you will see here is a future interface that we hope to use all of that information we've gained in that digital thread. So you could do some really interesting things, like highlight things are yellow if maybe it needs to replace or reaching its limited life. And we're doing this in partnership with Appian's product strategy team. The other thing I would highlight is over here on the right-hand side, you see Copilot. So again, once you've built that digital thread, you can start doing the really fun stuff, which is feeding these to LLMs to ask those really interesting questions that we're all trying to strive to. Now, Joe is going to have an opportunity to talk this more because we're running out of time here, but we really, really appreciate your time and look forward to a great Appian world. All right?